Good evening once again. Let me share my PPT. Okay. Yes. Welcome to the series on the center of mass. Which problem? Okay, fifth problem. Did I do the fourth problem? Oh, I have done it. Yeah. So in the few problems that we have seen, initially we looked at the center of mass. The first problem, the center of mass, and the geometric center of an equilateral triangle will not coincide. It's the first thing that we saw. And the second case also, we saw a similar example wherein, so there, okay, you had discrete masses. Here, you had complete masses wherein you had two disks, which were stacked one above the other. And then we found out that the center of mass will not be at the center between these two disks. In the third video, we observed in a gravity-free environment, when the ice melts, the particles of this ice will just be at the same point. As a result of this, this will not fall down. And hence, you see, the center of mass does not change over here. It will always be at the same point. And then we also found out a method to find out what is the center of mass of the system. And then this was equal to ml by 2 into m plus f. The fourth video, we observed something like relative motion, wherein you have a man of mass 50 kg, and you have a boat. The man is standing on the boat, and as he walks 2 meters per second. So with what speed does the boat move backwards? So the misconception here is that generally people consider Newton's third law of motion, which is incorrect. We should not use this. Okay, and we also looked at, and moreover, why shouldn't we use it? The reason is because you see, the person is moving at uniform speed throughout, which means this v has no value over it. Okay, it's something which we need to know. Okay, so which is not seen. So as a result of this concept is clearly a misconception. And then we took the example of, okay, how to find out using the center of mass equal to 0, putting the center of mass equal to 0. Why should it be 0? Because you see that it's because of the internal forces. Always remember, in a system, when there are internal forces, center of mass does not change. Very, very important concept. Okay, now let us look at this one. Now this concept, this problem was also worked on a similar basis. So towards it, two masses m1 and m2 are connected by a spring of spring constant k. I have two masses, m1 and m2. There are lots of parrots near my house, so you can hear them chirping. Okay, now it's connected by a spring, and then on a frictionless surface, there's no friction at all. Wow, very easy problem, right? Okay, initially the spring is stretched to a distance x naught. Always remember, when there is a friction, you can easily solve. When there's no friction, it's a headache. Okay, now when the system is released from rest, what we do is, okay, we take up one of these objects, we stretch it. Okay, it's not a relaxed position, it's in a stretched position. Let us say, for example, m2, I have just kept it like this. I have stretched it like this. I've stretched it like this. Okay, and then I leave my hand. When I leave my fingers, what will happen? Now these two masses, okay, so now when I leave my hand, this mass m1 will also move forward. This is my frictionless surface, right? It is not held over here. So this will move forward like this. M1 will move like this. And then the spring will contract like this. Will contract like this. M2 will also move like this. M2 will also move like this. Okay? Both of them will move like this. Because frictionless surface, right? Then when they come nearby, the compression is too much for the spring. And immediately the spring says, hey, don't come nearby to me. Okay, I'll kill you. So then finally, the mass starts moving like this, backwards. Right? So now the mass starts moving backwards once again. The masses will now start moving like once again. This is my m1, this is my m2, and once again it becomes like this only, right? So will they move to the same position? Of course, exactly, because you stretched it and you left it. No energy has been lost anywhere. So definitely the object will now come like this, and again I'm saying go down back. Good. Now, the logic is clear here. Find the distance moved by both the masses when they come to the distance. Then our students, what they do is, they say that since spring is stretched by x naught, means what? The distance between them is by x naught. And the moment you leave it free, what will happen? The two masses will travel equal distance. Very, very, very big mistake. Big blunder. Right? So why should they travel equal distance? No idea. Okay. He has assumed it like this. So therefore, the spring contracts again by x naught. So what happens? Spring contracts again by x naught. Total distance traveled by each object will be 2x naught. So initially, okay, this was at this point. This was at this point. Now it got contracted by x naught. Once again, it goes back to it. So thus the total distance could be 2x naught. Very simple. But this is a misconception. Okay, this concept is not clear. Why it is not clear? Reason behind this because we have different masses M1 and M2. M1 and M2 are not same mass, right? So as a result of this, so this is not the way how we think about it. Okay, what is the distance moved by it would be different over here. Now let us start working on the right concept here. Now, the moment you leave your fingers, when the spring is already stretched and you leave your fingers, then the masses start moving like this. What happens to center of mass? Does the center of mass change or will it remain same? It remains the same. It remains the same. Which means that now if I take XCM, it's along XCM, right? No YCM, no Y motion. XCM is equal to M1X1 plus M2X2 divided by M1 plus M2. Then dxcm. What is dxcm? Change in the value of xcm should now be equal to 0 because these are all because of internal forces, right? This pulls and then once again leaves, right? So for internal forces should now be equal to m1x1 plus m2x2 divided by m1 plus m2, right? This is what I should get. In other words, I should now write m1x1 should be equal to minus m2x2, or I should be able to write x1 equal to minus m2 by m1 into x2. That's what I said. If suppose if x1, okay, and say if m2 and m1 were same, then definitely m2 will be equal to m1 and x1 equal to minus x2, which means what? The moment you leave it, both the masses will travel equal distances. But here the masses are different. So therefore, this is incorrect. Okay, now we have got this relationship. But unfortunately, we do not know what is x2 here. We need to find. How do I find x2? What is x1, x2 here? X1 is the distance moved by the mass m1. X2 is the distance moved by the mass m2. Okay, such that x1 plus x2 is equal to x0. Do you agree with this? Why x0? Because what was the net distance? Both the masses you have pulled it across and you have kept it aside, right? So therefore, the total distance was x0. Now, of which one mass moved by distance x1, the other mass moved by distance x2, right? So now we have got this value. Now towards it. Now what we do is from here. Now we have got two equations here. Okay. I'll take this x1 value. I'll put it over here. So when I put it over here, what do I get over here? I get this as minus m2 by m1 into x2 plus x2 should be x0, or 1 minus m2 by m1 into x2 is equal to x0, and x2 should be equal to m1 x0 divided by, we make a mistake here. What is the mistake? See, when I say m1 x1 plus m2 x2, this x2 should become negative, right? Because if one is going forward, one is going forward direction, the other one should be moving backward direction, right? So you have two springs. You have two springs here. If I consider this direction as positive, this direction is negative. So this should have been negative. This should be negative. So therefore, this should be, so m1 x1 minus m2 x2 equal to 0, or m1 x1 should be equal to m2 x2, or x1 should be equal to m2 by m1 into x2. There's no negative here. That's a mistake we made. Okay, make it as positive. Okay, so now we get m1 x0 divided by m1 plus m2. Guys, you should have a notebook and pen with you while you work it out, so they get a clarity of this. So you get x2 equal to so much. What is x2 now? x2 is a distance moved by the mass m2. Okay, the moment you left it. Started from here. I'm not able to see by camera. Okay, so it started from here and it started moving like this. Right, this is your x2. Right. Okay. So this, now what happened was during one cycle, it started from here, it went all the way along to a distance of x2, and once again, when relaxed, it again comes back here. So what is the question asked? Find the distance moved by the two masses before they again come to rest. Before they again come to rest, which means what? Initially they were at rest. The moment you left it, it got compressed like this, and once again, it went back to the rest position. Right. So therefore, the total distance traveled by m2, okay, is nothing but it started from here, it went all the way along the mean position. Once again, it come back to same position, right? And once again, it starts. But anyway, you are supposed to find out what is this distance. It starts from here, goes here to the mean position, once again comes back to the same position. So therefore, total distance traveled is now equal to 2 times x2. 2 times x2, which should be 2 times m1 x0 divided by m1 plus m2. Okay. Now let us take as a special case of putting m1 equal to m2, which means what? I'll put the same mass. What will happen? I'll get this as 2 times m1 divided by 2 times m1 into x0, which means this will travel a distance of x0, right? And each object, I'm sorry, it's not 2x0, okay? Each object would have traveled a distance equal to x0, which means if the masses were same, then your logic would have been correct, okay? But since the masses are different, your logic is incorrect. Okay, so therefore, this is the misconception. So you should start solving the problems in this method. Now, in a similar way, if you ask me how to get the value of x1, see, we have got the value of x2 only. Okay, what is the distance moved by the mass m2 when the springs were, when your fingers were released? You got this. You can also get an expression for x1. How do you get x1? X1 is simple. I don't have space. Maybe I'll write it here. So what I can do is, I know x1 here is nothing but so much. So I will write x1 should be equal to m2 by m1 into x2. I'll substitute for x2 from here, which would be m2 by m1 into m1 x0 divided by m1 plus m2. So this m1 and this m1 goes away. And thus I am left out with m2 x0 divided by m1 plus m2. I hope, friends, you will like this video. So if you like it, do share and comment on my video and subscribe to my channel for further updates. Thank you, friends.